All right, mathematicians, let's get started with our new unit 3, starting with pairs of lines and angles, section 3.1. Our essential question, what does it mean when two lines are parallel, intersecting, coincident, or skew? So our objectives are that mathematicians will identify lines and planes, identify parallel and perpendicular lines, and identify pairs of angles formed by transversals. All right, let's start with parallel lines. Parallel lines have a special symbol. It looks like double hockey sticks. So there's our symbol for parallel lines. And we know that parallel lines are lines that do not intersect and are coplanar. So here's an example. We have lines A and B. They are parallel, and we have these special arrows that tell us and indicate that they are parallel. If we don't see these special symbols in our picture, we cannot conclude that we have parallel lines. So you can either just do simple little arrows, or you can do block arrows. But they must be matching for whatever lines are parallel. All right, so the symbol, double hockey sticks, means is parallel to, so we would say in this case, line A is parallel to line B. All right, next we have skew lines. These are lines that do not intersect and are not coplanar. Let's take a look at this cube where we can see edges that are highlighted with the pink arrow or red arrow. Those are edges that are not in the same plane. They also are not parallel. They won't intersect. They won't intersect. So that means that they are considered skew. We can pick a different pair of edges that are also skew. Street signs are a great real-world example. The street sign above another street sign are examples of skew lines. All right, so let's practice our understanding of parallel, skew, and perpendicular with example 1. It says identifying lines and planes. All right, so think of each segment in the figure as part of a line. So here's our figure. So every edge, which is our segments, think of them as lines, similar to what is sketched for line CD or edge CD. So our question is, which line or lines, plane or planes, if there's more than one, appear to fit the description? Here's our first description. Which line or lines are parallel to line CD and containing point A? Well, here's point A, and here's line CD. And we want a line that is parallel to line CD that contains point A. So that could be line AB. And that looks like our only example that would also contain point A, which is very important to the description. Next, which line or lines are skew to line CD containing point A? So again, here's point A, here's line CD. So skew could be line AH or line AG. Wouldn't be AB because that's parallel. And remember, skew is not coplanar and not intersecting. All right, next, name line or lines that are perpendicular to line CD and containing point A. So perpendicular means two lines that intersect to form right angles, 90 degrees. So containing A would be this line right here, intersecting CD. So we would name line AD. All right, and then our final description is plane or planes that are parallel to plane EFG containing point A. So the only plane that satisfies that description is going to be plane ABC. So we can see here ABC, A, B to C. So that's this top portion here. This very top part of the cube is a plane, and it contains point A and is parallel to this bottom plane or side of the cube, EFG. So here's E, F, and G. So that makes up this bottom portion of the cube, representing a plane parallel to the top portion. All right, so that takes us to our parallel postulate. Our postulate is that there is exactly one line through point P that is parallel to line L. In other words, a line and a non-collinear point implies parallel lines. So if there's a point not on a line, then there exists a line through that point that is parallel to the given line. That's our parallel postulate. So write down your implied statement, new one to memorize. We also have a perpendicular postulate. It states that there is exactly one line through point P that is perpendicular to line L. In other words, if there's a point non-collinear with any line, there exists a line through that point that is perpendicular to the given line. So our implied statement, write it down. A line and a non-collinear point implies perpendicular line. A new one to memorize. All right, let's practice these two new postulates with example 2. The given line markings show how the roads in a town are related to one another. So we've got double markings of arrows here and here, so that means these two lines are parallel. They have matching markings. And then we have this perpendicular symbol. So name a pair of parallel lines. So we can say line MD is parallel to line FE. All right, next, name a pair of perpendicular lines. All right, so there's our perpendicular symbol, so we can say this line and this line are parallel. So we can say that line MD is perpendicular to line BF. All right, and our last one is line FE parallel to line AC? Explain. So let's take a look. Here's line FE. Here's line AC. Kind of going at a diagonal, it appears. So it appears as if they're not parallel. So FE is not parallel. Remember, the slash through any symbol means not, to line AC. Here's the reason. Because line MD is parallel to line FE. We stated that earlier. And so by the parallel postulate, since it's new, it's a line and a non-collinear point implies parallel line. There's exactly one line parallel to line FE through point M. And since we already stated that line MD was the one parallel to FE, we can conclude that AC is not parallel because there is exactly one, and it's MD, not AC. All right, so we've got some more pairs of angles to learn about. So previous unit, we learned about linear pair, vertical angles. So now we're going to learn about more angle pairings. But first, we need to know what a transversal is. It's a line that intersects two or more lines, and it's highlighted in color here. This is considered a transversal. It's a line, and it's intersecting two lines or more. All right, so there's 4 different pairs of angles we can identify. The first is corresponding angles. These are angles on the same side of a transversal and in the same position at an intersection. And to kind of help you, you can make an F when you highlight it. So our list of corresponding angle pairs, we've got angle 1 and angle 5. Notice they're highlighted in red. And so my F that I can make is upside down with the 2 angles. So you've got angle 1 and angle 5. There's your F. You also can identify angles 3 and 7. So notice 3 and 7 are in a different position. So you've got 3 and 7 in corresponding positions. So you can make an F going this direction. And then you've got 2 and 6. 2 and 6 are here and here. So you've got an F going this direction, and then you've got 4 and 8. 4 and 8 are going this direction, so here and here. So corresponding angles are on the same side of the transversal and in the same position at the intersection. All right, next you have alternate interior angles. Angles on opposite sides of the transversal and between the lines. And it makes a Z when you highlight. So angles 3 and 6. So here's my Z. So 3 and 6 are alternate interior angles. And then Z going the other direction. So 5 and 4 are also alternating interior angles. All right, next you have alternate exterior angles. And these are angles on opposite sides of the transversal and on the outside of the lines. So here's a list, 1 and 8, and you can still make a Z, just like with the alternate interiors, except this time it's on the outside, exterior of the Z. So our other Z can go this way, so 2 and 7 are alternate exterior angles. Then our last pair are the consecutive interior angles. In other words, the same side interior. You can also call them a same side interior or consecutive interior. These are angles on the same side of the transversal and between the lines. You can make a C when highlighted. So our first pair are 3 and 5. So there's 3 and 5. Consecutive interior, same side interior. And the other pair are 4 and 6. So 4 and 6. All right, so let's just practice with example 3, identifying these new pairs of angles. So identify all pairs of angles of the given type. So our first given type is corresponding. Remember, corresponding angles, we can make an F shape and highlight sections. So let's take a look at highlighting. So we've got an F that we can make here, so 1 and 5. Next, we can highlight angles 2 and 6 to make an F, so 2 and 6. Next, I can highlight 3 and 7 to make an F. And our final pair are 4 and 8. All right, so now let's take a look at alternate interior angles. All right, so alternate interior angles forms a Z. So let's find our Z angles. So we can start with 2 and 7. They're alternate interior angles. And then we can flip our Z and identify 4 and 5. So we have two different sets of alternate interior angles. And then we can also use the same Z's to identify the alternate exterior, except this time you're going to go to the outside. So in this case, we can say angles 1 and angle 8. We also can identify 3 and 6 as alternate exterior angles. So exterior angles would be the ones to the outside of the lines, and then alternating means to be on opposite sides. So the 3 is the opposite side of this transversal, then 6. So 6 is on the top side of the transversal, 3 is on the bottom side. So they are on alternate. Alternate means to be on opposite sides, and the exterior of the lines. So 1 and 8 are alternate exterior angles, 2 and 7 alternate interior, 5 and 4 alternate interior. And then the last set of angles are the consecutive interiors. And consecutive interiors form a C. All right, so we've got two places where I can do a C. I've got a C here, so 2 and 5, and I can do a C on the other side, 4 and 7. So there's our consecutive interiors. Consecutive is one after the other, so they're on the same side of the transversal, and then interior would be the inside of these lines. All right, that's all for the first lesson of Unit 3. Bring all your clarifying questions and get ready to practice in class. See you then.